Okay, so good afternoon, everyone. My name is Petit. I work for Bull, and Marius is going to present himself later on. So we are going to talk about a project, XLcloud project, that is about remote rendering for games and 3D graphic application in the cloud. So that's, I mean, really the specific mission statement, I would say, that we think through in terms of XLcloud, but in reality, the scope of XLcloud goes a little broader than that, because we also strive to address high-performance cloud computing in general, so that we can also run HPC types of application in the cloud. So the presentation agenda is fairly simple and short, as we only have 15 minutes. So we basically have 4 slides, and we are going to have some video goodies as well for you. And for those who ask already, no, she doesn't work for us. We will have a light. Okay, so XnCloud is a collaborative project, very much like Open Cloudware. So it's a project that was a winner of the call for project for cloud computing project, the first call by the FSN, which is a government body, essentially, as everybody knows, that subsidize part of the development we do in this project. It's a 36-month project that we started early 2012 in January. The coordinator is Bull. I am the project lead. Everything we produce in this project is open source under Apache v2 license. And if you want to know more about what we've done already, there are a certain number of resources that you can take a look at. We have Git repos on the GitHub OW2 site. So there are multiple repos actually under the XLcloud umbrella. For those who are interested, there are already some interesting pieces of software that you can have a look, including a Java SDK for OpenStack. We are very much affiliated to OpenStack, because OpenStack is our cloud infrastructure, on top of which we develop our projects. We have a collaborative wiki under XLcloud.org that you can take a look at, although if you are not part of the project, there won't be much to see there. We have presentations, I guess, that you can have access to as a non-member. But if you want to become a member somehow, we could certainly open some pages for you. And I guess the third link is not the good one. It's supposed to be jara.ow2. This is where we handle basically our project. So everything is managed under Jira and Greenhopper. We are a Scrum Agile project. We have 3 months milestones and 2 weeks sprint. And that way, so far, we managed to deliver quite a bit of results. So now, in terms of presenting the team, we are 8 partners in this collaboration project. Atem, who brings an expertise in the H264 MPEG-4 AVC low latency compression algorithm. Bull, that brings his expertise in cloud infrastructure, distributed system architecture, and HPC cluster, which is a core competency of the company. We have the CEA list that has a lot of application and also a significant expertise in the domain of interactive simulation of natural phenomena and virtual reality, that brings in the project a lot of use cases that we want to validate, make sure that we can run those type of application in our clouds. That includes essentially a lot of virtual reality applications, serious gaming applications, like simulated environment for firemen, for instance, with smoke, for instance. And those games are used for train those personals, for instance. Those are the type of application we are targeting from a CEA point of view. ISTE, that is an engineering school. Their mission in the project is to work on the business apps integration, OpenERP, among others. INRIA Réseau is involved in energy efficiency developments in this project, and we already have some interesting stuff in Giterius. Telecom SudParis, Lab Artemis, headed by Marius, who's in the MPEG standardization and video compression and multimodality, but you'll know more about it in a few minutes. Silcan, who used to be a HPC project, that is expert in the domain of massively distributed, tightly coupled software architecture for interactive simulation. And OW2 also for the communication and dissemination parts. So I put together a certain number of items that we believe are really the key tenets and main objectives of the project. So I'll go through them one by one, and if you have actually questions during this walkthrough, you can interrupt me without problem. So the main paradigm of XLcloud is to provide virtual cluster instances on demand through a self-service API and a web UI. So what we produce in XLcloud are virtual cluster instances. So what is a virtual cluster? Well, that's essentially something that I called purpose-built platform as a service environments that are built for a certain type of applications. And it essentially targeted toward the final application that we want to run in those purpose-built platform as a service environments. So one typical application case would be the cloud gaming applications, but we also have other applications that we want to demonstrate in our use case, like HPC virtual cluster, for instance, where we are able to run HPC jobs on top of a virtual infrastructure, such as the one that is provided by OpenStack. Yes. A key objective is latency. Latency. Very low latency. So what we want to achieve is a point-to-point communication round trip below 200 milliseconds. Why 200 milliseconds? Because that's the time, and Marius is going to explain that much better than I can, but that's basically the time under which you have, as an end user, that feeling and sensation of sensitiveness of your application for a game, for instance. If you have latency that goes much beyond that level, you'll have that very bad feeling of a game being slow and not moving as you move or interacting with you as you interact with your devices like the mouse and so forth. So building a cloud infrastructure that is capable of returning or regenerating a video or an image in under 200 milliseconds is a no-no for us, right? It's a showstopper. Okay, 5 minutes total? Okay. I talked to standard compliance. So SAML v2, OS2, ZACML. So those are the standards that we expose in our APIs, Virtual Cluster Management Service API, modular layered and modular design to allow seamless support for many types of application and workloads. That's the purpose-built platform as a service computing environment that I talked about. Policy-based service level management, including automatic scale-up and scale-down. That's something that we look at. To give you an example, for instance, we want to be able to scale up and down a farm of compute nodes in an HPC virtual cluster environment, for instance, but also a compute resource for games. Business application integration framework, so that's for service composition and aggregation. That's essentially to be able to charge for different type of services, but they are not services as application. Services is like telco services. For instance, we could charge in the context of an HPC cluster for the number of jobs submitted or for the amount of CPU consumed by the virtual machines, but that's the business manager that put together the service and get access to the metrics that will be able to that it will use to be able to charge the customer based on different service plans. Secure multi-tenant environments, isolation, strong authentication, and so forth is part of the game. Fine-grained resource usage metering, and energy efficiency, which really means produce the most output for the least cost. And it really matters very much to be able to save energy in the cloud, because that represents 60% of the cost.
Your 15 minutes are already gone. Okay. So as you understood, actually we are in a specific kind of applications about the cloud. In the cloud, we are talking about interactive cloud. It means I press a button, I should have the answer immediately. Patrick mentioned 200 milliseconds. Some games even require much less than that. Let's understand. I have a diagram. I hope I have it in one minute. Let's understand why, what kind of operations we have to do in these 200 milliseconds. In remote rendering, by the way, everybody now is talking about cloud gaming. Is something that even the church here proposed to the customers. We will see that there is a difference between what does it mean cloud gaming and remote assistant, server assistant gaming. However, let's try to see what is happening in the chain. Mainly, we have a game that has two main components, application engine, game engine. I'm talking about games, but in general, it's about applications, 3D and 2D graphics applications. And on the other side, we have the rendering engine. We have entries that can be AI, data, scene description, and once this goes in the game, what the game engine is doing is producing an image. Okay. What is now happening in the remote rendering scenario is that these images are encoded. We have to reduce the size of the data, obtain a compressed stream that is packetized with respect to some network protocol, transmitted to the network by a streamer, and on the client side we are receiving this data, unpacketized, and play, obtaining exactly the same image. Then we have to capture the interactivity from the user, mainly keyboard and mouse, and that is not sent back to the player, but is sent back to the server by using the same network connection. This is the user interaction that is going in the application engine, and the entire loop is repeated. In addition, what we can have is we may have some terminal preferences. Our users will not use the same platform, so these terminal preferences will go in the network and will somehow drive the game itself. More than terminal preference, we may have network preferences. This is the global scenario of remote rendering. And now, because in the cloud we have as much processing power as we want, the idea here is how to minimize the latency. The main latency in this schema is coming from the network transmission. So in general, you have some agreement with the network operator, and something special is doing there. But we can do even more. We can reduce that latency because we can reduce the data to be transmitted. And why we can do that? Because we have the power of the cloud. So there are additional operations that are possible to be done. I will give some examples. We can extract the depth map and input that depth map in the video encoder. It will run not faster, but better in terms of results. Then we may even analyze the scene, and by doing so, we can detect some motion vectors. We will input that in the video encoder, and we will not do any more frame prediction in the video, so it will be faster. Even more than that, we may do a segmentation map and control the quality in the image, specifically to what is important in the game. Even more, and this is one of the goals in XlCloud, we can have a kind of mixed representation of the data. Instead of having only pixels, we may transmit 2D graphics and 3D graphics because we have the power to interpret all this data and send probably to a graphics encoder, put it in the compressed stream, and the scene will go back. The scene will continue. So this is the overall schema. Many components are not yet available. Some of them are available, are even commercially available, and XlCloud will advance on these new components. Here you have two videos that are showing actually the current situation. Here you have a TV set with a very tiny set-top box that is only doing video encoder, and the mobile phone that is only taking the input. And the game itself, which is displayed here, is done on another server in the cloud. There are many advantages of doing that. I'll not go there, but you have multi-platform, multi-session immediately because you have only one instance that you can access.